Okay, well, nice. That's say well or okay. So while you students are on your way down to run like you're late for science, I'll I'll continue and our lone student finishes or is done rolling on the floor laughing. So yeah, yeah. Or the crickets stop chirping. Okay, so as you had noticed yesterday, just said would say begin chapter 12, which is proteins, and we had actually introduced proteins not just last year in general chemistry, but also in anatomy and physiology, not for the reasons that you might think. Well, maybe you would, because on that table that categorize these enzymes, that categorize these hormones. Oh boy, it's great that you're in a class all on your own, or a class by yourself. Yay! Okay. Okay, so the first biggest way to break down hormones is what and what possibly. Because if you had test steroid hormones and cholesterol makes a steroid, so you're not wrong. You're just saying the same thing twice. And non-steroids, okay? So then if we know that cholesterol is the building block for steroid hormones, which they are, well then there must be a component that makes up these non-steroid hormones, which would be true because some of them are what we call polypeptide based. Of course that rings a bell, right? Yeah, I remember that. And some of them are amino acid based, okay? So even we categorize that amino acids are just building blocks of proteins. That's not necessarily true. Now, there's a little more information that goes into a really long chain of amino acids that makes a hormone. There's some, I suppose you could say, other components attached at the end of that amino acid chain. So the more complex that a hormone would be, and we categorize it that it travels throughout the entire body, okay, as opposed to perhaps a localized effect. More of that type of a hormone like oxytocin and ADH or antidiuretic hormone are polypeptide based. And we had meant that that was just maybe 12 amino acids put together. The thyroxine, on the other hand, that controls so many different types of activities throughout the entire body, has a really long chain of amino acids put together. Of course, there's no reason that we would even go that far in depth as far as, well, what amino acids make up that of even antidiuretic hormone, ADH, or oxytocin, or anything like that that are polypeptide based, which is only 12. Because I think that would be kind of silly to do that. But we will be responsible for those that are on page, what is the page number? Okay, 600 and 601. So when we look at this will be handed out to you tomorrow. Just has different ways that we want to categorize the functions of some of these, I almost said hormones again. But anyways, proteins, okay? And then what we want to do is it's actually on the back of page 2, page 3, and then page 4, okay? There are the listed amino acids that we want you to make. And we briefly talked about that yesterday. And this is perhaps the best way to do this. Of course, everyone's going to approach this in a different manner, okay? To me, if it works for you, just looking in the book and memorizing, looking in the book and memorizing. Some people that might work, okay? And this is what we talked about yesterday, just making some of these flashcards. And even having these now may not be the best way to do it, because then if you just have the flashcard and then look or turn it over, you're really doing nothing different than looking in the book. But again, if that's what works for you, keep doing it. You're all successful enough and made it this far and doing quite well that you might not want to change that. Okay, because I think when you write these down, I think it's just easier to make a correlation to the different types of structures. So, very briefly, yesterday we had mentioned what makes up an amino acid. Okay, so what would possibly be an amine? Okay, so the question is really hard. Okay, it sounds like it's really, really difficult. But if you had to write out an amino acid, okay? So can you just, because what you see on 600 and 601, that doesn't provide you any content. That's how they all attach to the parent chain, okay? But then what we see here, okay, this is our parent structure here. These are all just the different types of ways they attach to the parent chain, okay? So then when you look on the top of page 601, what do you visualize there? What does it tell you? At least that's the way I look at it. Did I say six? I meant 600. Top of 600? Yeah, that. Yep. My mistake, your fault. Or my mistake and my fault. Okay, so yes, NH2.
No, NH2 and then a dash.
Oh, okay. So you're not wrong, okay? Rather than doing, I think this, and this will make more sense when we get further down the road, okay? 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 And then when you say CH, yes, that's right, but we're going to put that on top, okay?
Dash. See?
Of course I see.
Oh.
Don't you see? I see. Don't you see? See?
Letter C.
Oh, letter C. Oh.
Dash. OH. Go up above the second. Yep. And put a double bonded oxygen.
Okay. Now, the way the book does this, I don't like it. So what I mean by that is, notice this is just the exact opposite of what we did. Okay? What is R besides pirate talk? What do you suppose R means? Yeah, it could be a methyl group, it could be an ethyl group, it could be a propyl group. So what we're trying to describe is that in the textbook, okay, it'll have that hydrogen down here, and then it has an R group up there. And of course, R, okay, can mean, like you said, a methyl group, an ethyl group, anything that's a variable that attaches to that chain. So that's right. Okay, but rather than putting that R on top, we want to put the hydrogen there, because everything that attaches differently, all your different types of structures that you find on page 600 and 601 will actually attach down here. And even though we're not putting an R here, this is an amino acid. Even with nothing on here, it's just hydrogens. That is glycine. Well, it's in there. So now when you look at this, maybe this should be some of our, what I want to call it, student learning objectives. Holy cow, starting with this back in August, saying, okay, I want you to draw out these amino acids. Yeah. And then just think of how far you would have come along. Now, The only thing that, for our purposes that we're going to do here, okay, is that we're going to apply just a little bit of general chemistry here because nitrogen is in which column on the table? Because that's important. So, why? That must mean that, okay, 1, 2, 3, okay, then there's a couple of unshared pairs of electrons here because these are being shared, okay. For our purposes, to me, you're demonstrating a greater knowledge by putting those two dots up there, okay, and that's what we're going to do, okay, because then on the end of these, and we know this, there's an X there because there's a hydrogen. There's an X here, and those are the electrons that come from the hydrogens, okay? You could really break this down to an electron dot diagram if we wanted to, but that would be really, really silly to do, and we don't want to take that time. Okay, but for, again, just moving forward, okay, we want you to draw every amino acid like this, whether that's glycine, okay? And one of the things that I was impressed by is we got the ball rolling, and some of you young ladies and gentlemen said, well, yeah, well, I remember, okay, lysine, leucine, isoleucine. Maybe I'm not pronouncing right either. Okay. And then if we put a methyl group here, okay, now we have alanine, okay. Then if we put an isopropyl group here, now this to me is one good way of associating that, okay. And if you draw them in a straight line, there's nothing wrong with that. If you just want this to be 180 degrees, we've got this at about, I don't know, 121. I thought it was 120. Yeah, we're going to say it's 121. Whether that's accurate or not, I don't know. The reason for that is, since we have this inverted, okay, even though it's upside down, what letter is that? But no, if it's upside down, okay, you're putting it on its side. Uh-huh. So then that must mean this would be which amino acid? Valine. So when you draw it like that, that's one way to remember, okay, whether you see it or whether you write it, that is valine. Then, okay, we're at 13 minutes. I'm just going to really throw a curve at. No. It's not one to where, oh my gosh, he's asking me a tough question. No. I'm not even going to look at my flashcards, okay? It's because it's a way that we can make an association. The reason I say that is you're going to have a little bit input too, okay? The reason I say that is cysteine or serine. I want to make sure if I'm getting the name of that right. Okay. Yes. Cysteine or serine. I had to look at the names. You pick. Okay? Because, gosh, now I'm probably going to get this wrong. Okay, I know there's a carbon there. I want to say that's right. Okay, so now I'm going to look at my note cards. Okay, so okay, so then yes, that's in the right spot, but it's probably just a matter of interpretation that it actually has it written like this instead. Okay, because I had that sulfur up there. Okay, and it's one of the aspects to where you're applying some of that general chemistry that you learned with the idea of now what column is sulfur in on the table. So that must mean it wants how many bonds, how many more electrons to make it to 8. Yeah, so then that's why there's 2 bonds. There's one to this carbon, there's one to that hydrogen. So we had called this cysteine, that's what I pronounce it as cysteine, is that, okay, every time I think of cysteine is a chapel. Okay? So then you wouldn't even have to have visited here, or there, I should say, not here. You wouldn't even have to visit over where the Sistine Chapel is. Have you ever heard of it before? Okay. And is it Leonardo painted the Sistine Chapel? I don't know. Oh, it might have been Michelangelo. But if you're standing there and you're appreciating that art, you would say, shh, it's the Sistine Chapel. You have sulfur and hydrogen going shh. Even though when you say shh, isn't there like a lot more H's? But this is a way to associate that. Shh, looking at the Sistine Chapel. Okay, that's why I said we're going to go further down the line. All right. So then, if our original idea, I had it like this. Okay. Notice that I believe you could say that that's the same. It's just whether it's down here or on the side. Still kind of. All right. We will stop there for today. Your handout will have the components or the list of amino acids that we want you to know. Because this isn't a very long chapter, we want you to know this, and then eventually we start stringing these amino acids together and start to make protein. So that's about enough. Wanted to keep it under 20 minutes. We're right at 18, so I think that will work. We will catch up to you next time.